So let's consider a pendulum problem. So we have a pendulum. We pull it off to the side, let go, and I want to know how long does it take to get to the bottom, how fast is it moving when it gets to the bottom, and how long does it take to get back where it started from. Okay, so I need to know the length of the pendulum, 2.11 meters. Everybody always asks for the mass of the thing, so let's say it's 2.5 kilograms. Turns out that doesn't really matter because that all cancels out. Okay. How long does it take to get to the bottom? Well, we know the time to get to the far side and back is 1 period. So therefore, the time it takes just to get to the bottom is going to be 1/4 of a period. So the time is going to be 1/4 of a period. The period is 2 pi square root L over G. Okay. And so this is 1/4 of a period. So that means this is going to be equal to pi over 2 square root L over G. So that's pi over 2 square root 0.211 meters divided by 9.81 meter per second squared. And so the time comes out to be 0.728 seconds. So that's the time it takes to reach the bottom. Okay, so while we're at it, the time to return is going to be 4 times that. So 4 times that is going to be equal to 2.91 seconds. So this is the time to the bottom. And this down here is the time to return. Okay. So the next question is, how fast is it moving when it reaches the bottom? Okay. Now, well, we actually have an easy way of doing this too, because we know that this is a conservation of energy thing. So kinetic energy plus potential energy equals final kinetic energy plus final potential. So we'll say that the initial kinetic energy was 0, final potential is 0, so the mgh equals 1/2 mv squared, so v is square root 2gh. We've done this problem before. So h, that height right there, is going to be equal to L times 1 minus cosine theta. Okay. And so the velocity will be square root of 2 times 9.81 meter per second squared times 2.11 meters times 1 minus cosine 18 degrees. And so that comes out to be 1.42 meters per second, conservation of energy. So, pendulum problem.